My name is Higgs and this is my friend Boson. Welcome to the Higgs world.
Thanks for the introduction, Higgs. In this presentation, our goal is to offer you a quick summary of the research and conclusions. We follow inquiry-based learning model where students take lead in learning.
First, they get a quick review of the research via the videos. Second, they review the paper to learn and understand key concepts. Finally, they can follow up with further research on their own to dig deeper. In the end, students would have learnt something new, latest and relevant. Isn't that wonderful, Boson?
Great point, Higgs. Please follow the links to review the research in further details. We want to thank all the authors and publishers for making this research public, thereby advancing science and innovation. Please like, share and subscribe.
Today, we are reviewing a paper titled, Accelerated Mass Loss of Himalayan Glaciers, Since the Little Ice Age. Meltwater released by Himalayan glaciers forms the headwaters of the major river systems in Asia, supporting food and energy production downstream, as well as maintaining a range of ecosystems and ecosystem services. Thinning of Himalayan glaciers raises concerns about the sustainability of water supply in the region.
There has been no consideration of whether the magnitude and rates of glacier mass loss, presently reported across the Himalaya, are unusual in a longer term or in the centennial scale context. Long-term fluctuations of mountain glaciers are known to be controlled primarily by regional climate and topography. In this study, the researchers made the first assessment of Himalayan glacier changes over a centennial time scale. Specifically, this assessment was achieved using a combination of geomorphological mapping and paleo-ice surface reconstruction techniques.
That is so intriguing, Boson. The researchers inferred the extent and surface elevation of 14,798 glaciers during the Little Ice Age maximum. This study provides the first self-consistent measurement of Himalayan glacier extent and surface elevation during the Little Ice Age maximum, across the entire Himalaya. The Little Ice Age was a period of pronounced climate cooling that culminated between 400 and 700 years ago across the Himalaya. It represents the last period of widespread glacier expansion in the Himalaya and is therefore the benchmark position from which modern glaciers are currently receding.
The area loss of Himalayan glaciers since the Little Ice Age has been at least 40% of the Little Ice Age extent. Ice volume loss since the Little Ice Age has been between 390 and 586 cubic kilometers. We can draw some important conclusions. Firstly, by comparison to other world regions, the magnitude of the acceleration in glacier mass loss across the Himalayan region is exceptional. Secondly, whilst centennial scale changes in climate forcings alter spatial gradients in regional glacier mass balance, it is local topography and glaciological attributes such as debris cover and the presence of a proglacial lake that promote rapid mass loss.
Thirdly, those attributes need to be accounted for, in numerical models because they are important drivers of mass loss. Overall, quantification of past glacier variability over a centennial timescale should help validate climate glacier numerical models and thus produce more reliable projections of future mass loss under a warming climate. That was an interesting paper to review. Hope you liked it, Boson.